Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the January 2024 Pure Mathematics P4 International A-Level Edexcel exam. This question here is about vectors, and we said relative to a fixed origin O, the lines L1 and L2 are given by these following equations. So you have these vectors in component form, I, J, K, three-dimensional vectors. The first part of each vector here, that represents the position vector of a point on the line, and the second part of the vector here, that is multiplied by the scalar parameter, is representing the direction that the line is going in. Okay, so we can say that, let's say, these are the direction parts of the vectors and these are the position vectors of points on the line. So we're told that these two lines intersect at a particular point, and we know that this is given that they intersect, so for sure they do intersect. And given that they do intersect, we got to find the value of P, which is this letter which represents the number here. We got to find its value. So I'm going to use the fact that if they intersect, then they will have the same position vector. There will be a certain point which they will both pass through. Okay, they'll both pass through a particular point, and that point will be the point at which they intersect. And the position vector of that point will be the same, of course. So there will be a value of lambda and mu for which these two will be exactly at the same place. So what I'm going to do is I'm going to write line 1 and line 2 in column vector form, because I find it much easier to deal with in terms of calculations. So I'm going to have 3, okay, and P and 7 plus lambda times 2 and minus 5 and 4. Be very careful to write things, everything there. That's going to definitely equal to the vector 8 and minus 2 and 5 plus mu times 4 and 1 and 2. Okay, there's definitely going to be a value of lambda and mu for which these two are going to be at the same place. All right. So now what I know is if I take the I component and the K component, which are complete, I can use those two components. I can make two equations and I can solve them simultaneously to find lambda and mu, and then I can use the values of lambda and mu that I find to find what P is. So I'm going to take the I component, which is 3 plus 2 lambda, and that's equal to 8 plus 4 mu. Okay, and the K component, which is 7 plus 4 lambda, which is equal to 5 plus 2 mu, and I'm going to solve these two equations simultaneously. So what I could do, for example, I could multiply this one by 2, in which case this is going to become 6 plus 4 lambda equals 16 plus 8 mu. So now these two equations, I can solve them simultaneously. I have the same number of lambdas, so I can subtract them. So I can subtract, so I've got 7 minus 6 is 1. This is going to give you 0 equals 5 minus 16 is negative 11, and 2 minus 8 is minus 6 mu. So I can say that 12 is equal to negative 6 mu. Therefore mu is equal to minus 2. Alright, and now I can find what lambda is by substituting it back, say, into this equation. So I can say 3 plus 2 lambda is equal to 8 plus 4 times negative 2. So 3 plus 2 lambda is equal to 8 minus 8, which is 0. So 2 lambda is equal to negative 3. Lambda is equal to negative 3 over 2. So those are my values of lambda and mu. Okay, so I know those values of lambda and mu. I can now use the j component of my equation of this, I have p minus 5 lambda equals minus 2 plus mu. So I can substitute the values in of lambda and mu. So p minus, this is at the point where they intersect. So I've got lambda is minus 3 over 2 equals minus 2, and mu is minus 2. So I end up with p plus 15 over 2 equals minus 4. So p is equal to, I'm going to convert this into over 2, sorry, so that I can add these together. So minus 4 is 8, minus 8 over 2, take away 15 over 2. So that's going to give you p is equal to minus 23 over 2. So that's the value of p, minus 23 over 2. Okay, so now we know the value of p, minus 23 over 2. So that's the answer to part A. Now we're going to go on to part B. It says find the position vector of the point of intersection. Okay, so we worked out that p is equal to minus 23 over 2. All right, and we worked out the value of lambda at the point where they intersect was minus 3 over 2. This is just at the point where they intersect, minus 3 over 2, and the value of mu was minus 2. Was it minus 2? Let me just make sure. Yes. Okay, so we know those points. Okay, that we know p is equal to negative 23 over 2. That's a constant. But lambda and mu, this is the value of lambda and mu. Okay, at the point of intersection. You can say at the intersection point. At intersection point. So we can take either of those two, and I would choose line 2. Why? Because we know for line 2 we have all the values, and p, if we made a mistake, that could cause some problems. So it's better to use what we know for sure. So we have 8 minus 2 and 5 plus mu times 4 and 1 and 2. So therefore when mu is equal to minus 2, then the position vector of the point where they intersect is going to be 8 minus 2, 5 minus 2 times 4, 1, 2. So that position vector where they're going to intersect is going to be 8 minus 8, which is 0, and minus 2, which is negative 4, and 5 minus 4, which is 1. That's going to be the position. It says the position vector of the point they intersect. So this is going to be that point. They want it as a position vector. They don't want it as a coordinate of a point. In fact, what would be better for us to do is to write this in component form, IJK form. So this is going to be 0i minus 4j plus k. That is the point at which they intersect, the position vector of the point at which they intersect. Okay, now for part C, it says find the acute angle between line 1 and line 2. Give your answer in degrees to 1 decimal place. So when you have two vectors which intersect, okay, and we want to find the angle between them, okay, say this is the direction of one vector, this is the direction of the other one, say this is line 1 and this is line 2. The angle between them, theta, is going to be found by using the formula. The cosine of the angle between the two vectors is equal to their dot product over the product of their magnitudes. Now, when we're talking about a vector equation of the line, the part of the vector equation of the line which determines the direction of the vector is the part which is multiplied by the scalar parameter. That tells you about the direction of the vector. That tells you about a point on the line of the vector. So this is what will help determine the angle between the vectors, not this part here. So we can say let A be the vector 2, minus 5 and 4, and let B be the vector 4, 1 and 2. So we can say that the dot product of A and B is going to be, when you multiply those two vectors together, the scalar product is called. It's very simple to find that. You're going to have to just multiply the I components together. So 2 times 4. Add together the j components minus 5 times 1, and add to that the product of the k components, 4 times 2. That's going to give you 8 minus 5 plus 8. That's going to be 16 minus 5, which is 11. Okay, so that's the dot product. And we can see that the magnitude of the vector A is going to be the square root of 2 squared plus 5 squared plus 4 squared. We don't have to worry about the sign because it's going to get squared anyway. That's going to be the square root of, that's 25 plus 4, 29. 29 plus 16, that's 45. Okay, let me just confirm that. We're going to have here 2 squared plus 5 squared plus 4 squared. That gives us 45. So the square root of 45, okay, which we can write it in, doesn't have to worry about third form, simplified third form. And the magnitude of vector B is going to be 4 squared plus 1 squared plus 2 squared. That's going to be the square root of 16 plus 4, the square root of 21. 16 plus 4 plus 1. Alright, so we can therefore say that the cosine of the angle between those two vectors is going to be 11 over root 45 times root 21. So we can find theta by doing the inverse cosine of this. Okay, it's going to come out as an acute angle, which is what we want. If it came out as obtuse, we would do 180 minus that to give you the answer. So we have inverse cosine. We're in degree mode, yes we are. We have 11 divided by the square root of 45 times the square root of 21, and we can close that bracket. Inverse cosine, we need to find inverse cosine. Why did I not press inverse cosine? So I've got to do inverse cosine. I must have forgot to press the inverse. So that should give us our angle, which is 69.033, 69.033, which we want to write to 1 decimal place. So theta is going to be 69.0 degrees. And there's the answer for part C of this question. And now we move on to part D. Okay, so part D says a point A lies on L1 with parameter lambda equals 2. The point B lies on line 2 with A to B perpendicular to line 2. Find the coordinates of B. So I'm going to draw a diagram again. We know that you have line 1 and you have line 2. You have the angle between them is 69.0 degrees. 69.0 degrees. In fact, what I'll do is, in case we need to use this again, I'm going to store this as A. Alright, so it's in its exact form. Okay, so that's the angle between them. Alright, the lines are tail to tail. Alright, it says the point A lies on line 1 with parameter lambda equals 2. The point B lies on line 2 with AB perpendicular to line 2. Okay, so supposing this is, I have to draw a line perpendicular to line 2 like this. I'll do that. It's always good to draw a diagram. So this must be A, and this must be B. It could be anywhere on the line, but I'm just drawing them randomly at place. But just to show that this is perpendicular, okay, the line AB is perpendicular to line 2. Okay, so we got to find the coordinates of the point B. So what I'm going to do is I'm going to just choose a random place to put the origin. Let's say over here. Okay, everyone's diagram will be different. All right, 3-dimensional diagrams, you can't draw them, of course, accurately, but I'm drawing these in here so that I can figure out what to do. I've got to find the coordinates of point B. So that will be found if I find the vector from, let me just tidy this up a bit, the vector from O to B. If I know the vector O to B, that will tell me the coordinates of B, basically. So this is the point B. Okay, that's a right angle. That's A. Let me just tidy it up so that I've got everything looking better. Okay, so what do we know? We have to find O to B. That's our goal, is to find the vector O to B. That's our goal. All right. Now, the vector from O to A we can find. How? Because I know that A lies on line 1 with parameter alpha equals 2. So I can say that the vector from O to A is on line 1 when lambda equals 2. So I can take this line 1, so I have 3 and 23 over 2 and 7 plus lambda, which is 2 times, we're going to have 2 and minus 5 and 4. Let me just make sure it is 23 over 2 minus 23 over 2. So you have to be careful. It's minus 23 over 2. That would have messed everything up. Okay, plus 2 times 2 minus 5, 4. That will tell me the position vector of A. So I have 3 plus 4, 3 plus 2 times 2, 4, which is 7, minus 23 over 2, minus 10. Okay, so I'll just do that here. Minus 23 over 2. So minus 23 over 2. Whoops. Minus 23 over 2. And take away 10. That's going to be minus 43 over 2. That's minus 43 over 2. And 7 plus 8, which is 15. Okay, so that's the vector from O to A. Okay, that's O to A. So we found O to A. Now we need to find the vector from A to B. Okay, what do we know about B? We know that B lies on line L. Okay, and we also know that the vector A to B is perpendicular to the line 2. Okay, so we can let's call the position vector of B X and Y and Z. Okay, that's the vector that takes you from O to B. X, Y, Z. Okay, so what I know is that the line that B lies on the line L. So I know on the line 2. Okay, so line 2 is 8 minus 2, 5. So 8 minus 2, 5 plus mu times 4, 1 and 2. 4, 1 and 2. So I know that there's going to be a value of mu that takes us to this point X, Y and Z. For sure. So from this I can form 3 equations. 8 plus 4 mu equals X, and minus 2 plus mu is equal to Y, and 5 plus 2 mu is equal to Z. So I have these 3 equations that I have formed from the fact that this point lies on this line. Okay, so that's one thing I'm going to use. The other thing I'm going to use is the fact that the line AB is perpendicular to the line L2. Okay, so their dot product will be 0. So what is the vector from A to B? Well, I know what O to A is. We just worked it out. It's 7 and minus 43 over 2 and 15. That's the vector from O to A. So we can say that the vector from A to B is going to be minus this plus that. So it's X, Y, Z minus this vector. So we can say that the vector from A to B, we know that the vector A to B is perpendicular to the line L2. And the vector from A to B is going to be OB minus OA. And OB we know is, well, we don't know what it is, but it's X, Y, and Z. And we're going to have minus the vector O to A. So minus 7. So X minus 7. And Y minus 43 over 2, which is plus 43 over 2. And Z minus 15. Z minus 15. Okay. So that's the vector from A to B. And I know that the dot product of these two vectors is going to be equal to 0. So the vector A to B times the direction of line 2 is going to be equal to 0. And line 2, its direction is given by, okay, the line 2, its direction is given by 4, 1, and 2. So we have x minus 7 and y plus 43 over 2 and z minus 15 multiplied by the direction of line 2, which is 4, 1, and 2. We know that that has to equal 0 because they're perpendicular. So I can say from here that 4 times x minus 7 plus y plus 43 over 2 times 1 plus 2 times z minus 15 definitely equals 0. So if I expand this, I have 4x minus 28 plus y plus 43 over 2 plus 2z minus 30 equals 0. So I have 4x plus y plus 2z. Okay, and then I have minus 28 minus 30, which is minus 58 plus 43 over 2 equals 0. So I can say 4x plus y plus 2z equals, what's that going to equal? You have negative 58 plus 43 over 2. That gives us negative 73 over 2. Okay, so we add that to both sides, so that'll be 73 over 2. So now, what we can do now is use the fact that we now have x equals 8 plus 4 mu, and y equals minus 2 plus mu, and z equals 5 plus 2 mu, and we can substitute those into here, and that will tell me the value of mu, where b is, and then we can find out the position vector of b. So it's a bit long, this type of question, but that's how we go about doing it. So now we got 4 times 8 plus 4 mu, so we have 4 times 8 plus 4 mu, sorry, 8 plus 4 mu, that's x. 8 plus 4 mu. Then you're going to have plus y, okay, and y is what? Minus 2 plus mu. So we can just put minus 2 plus mu. And then we're going to have plus 2z. So we have plus 2 times 5 plus 2 mu. Plus 2 times 5 plus 2 mu. And that's equal to 73 over 2. So we have 4 8s are 32. Plus 16 mu. Minus 2 plus mu. Plus 10 plus 4 mu equals 73 over 2. So we have 16 plus 1 plus 4, that's 21. So 21 mu. 32 minus 2, that's 30. 30 plus 10, that's plus 40, is equal to 73 over 2. So 21 mu is equal to 73 over 2 minus 40. Okay, so you have 73 over 2. Take away 40. That gives you minus 7 over 2. So 21 mu is equal to minus 7 over 2. So mu is equal to minus 7 over 2 times 21. Okay, that cancels with that, giving you 3. So mu is equal to minus 1 over 6. Now, if mu is equal to minus 1 over 6, we can find the position vector of, or the coordinates of b. We put minus 1 over 6 inside this equation here. Let me just take the equation down. Whoops. What am I doing? Moving everything. I just want that. Okay, so now I'll put this over here and keep the answer on this page. So I'll just leave that there for now. So we need line 2, we need mu, so we can say that the position vector now of the position vector we're looking for. Okay, so now we will use this value of mu as minus 1/6 and put it into the second equation. So we can say that what we're trying to find, which is the coordinates of B. Okay, because first of all let's find the vector from O to B, therefore is going to be equal to this 8 minus 2 and 5 minus 1 over 6 times you're going to have 4 and 1 and 2. Okay, that's going to tell you where B is. So that's going to be 8. You have 8 minus 4 over 6, 8 minus 2/3, and minus 2 minus 1/6, and 5 minus 1/3. Okay, so 8 minus 2/3, that's 24 over 3, minus 2 over 3, that's 22 over 3. And minus 2 minus 1/6, that's minus 12 over 6, minus 1 over 6, that's minus 13 over 6. And 5 minus 1/3, that's 15 over 3, minus 1 over 3, that's 14 over 3. So we can say the coordinates of B are going to be 22 over 3, minus 13 over 6, and 14 over 3. And those are the coordinates of the point B. Okay, so this is quite a typical type of question. We know two things about the point B. It lies on line 2, and it's perpendicular to line the line A to B. Okay, so and then we can work out what its coordinates are using this method. Okay, so there's the answer to part D, and I think that was the end of that question. Yes. Okay, so this wraps up question D, 6D, and question number 6. You can find other questions from this paper by clicking on the link over here from this January 2024. Other questions from vectors of P4 you can find in the playlist over here. You can subscribe to my channel by clicking on this link, and the video at the top here, if you click the link, will take you to the video which will explain to you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.